All right, so what I said earlier about this being practical is what we're going to do right here. We're going to eventually solve for missing angles and missing sides of a right triangle. All right, right now I got to teach you something. Let's see, what do I want to do first? Is that what I want to do? Give me a sec. Oh, okay. I see what we're doing. All right. I'm just going to jump right to example 2. Example 1 is it's basically what we just did. I'm not really sure why they did that example 1. So let's do this. Let's do example 2. It's got a right triangle. Remember these trig things, these trig ratios is what they call them, is only works for right triangles. Remember that. So here's a right triangle, and this is example 2. And what they do is this. They ask you, this is kind of a weird thing. They haven't asked you to do this in the past, but they say solve the triangle. It's like, how in the world do I solve a triangle? Well, you're basically just solving for all the missing parts of that triangle, okay? So anything you don't know, that's what we're trying to find. So let's see what they tell you. They tell you this angle up top here is 72 degrees. They tell you this side right here is 8, and it's in centimeters. They don't tell you this side, they don't tell you this side, and they don't tell you this angle. We'll call that angle A, we'll call this C, we'll call this B. Okay? Everybody with me so far? There's one thing that we can solve for that's the easiest thing to solve for, and you don't have to know any trig at all to be able to solve for it. Take a look at it, think about it. Which one of these things could we solve for B? Could we solve for C? Could I solve for angle A without knowing any trig at all? The answer is yes. Okay. What would we do and what would we solve for? Angle A. How would I solve for angle A? Well, you know this is 90 degrees. Okay. Okay, you could do that. All right, and that'd be fine. I'll give you a little streamlined way to do it. All three of these add up to what? 180. Okay, this is already what? 90. So anytime you have a right triangle, these two angles will always add up to what? To 90, right? Would you agree? Because 180 minus 90 is 90, so these two must add up to 90. So what's the quickest, easiest, most streamlined method that I could solve for A? You got it. 90 minus 72. Whoops. And that's what? 18? 18 degrees. There you go. You found one. And you didn't have to know anything new. That was pretty simple. All right? So let's put that in here. 18 degrees. All right. Well, that was good. That was easy. But now let's use the stuff. Let's use that sine, cosine, tangent stuff. This is the first time that we're actually using it to find something that's missing. All right? So what do we use? We could use this angle 18, or you could use this angle 72. All right? It doesn't matter which one you use. So let's use, which one? You tell me. Which one would you rather use? The 72? All right, let's use the 72. So let's use this angle right here. Now, I got to figure out which trig function am I going to use. Am I going to use the sine, the cosine, or the tangent? All right, well, we got to see what they give us. And then that's going to determine which trig function we're going to use. So what do they give us? They give us this 8. Zion, what's this 8 to this 72? It's adjacent, right. So they tell us, I'll just write that down. They tell us the adjacent side. What else do they tell us? I'm sorry, they don't tell us anything else as far as the sides. What do you want to solve for first? It doesn't really make any difference. You want to solve for C first? Okay, let's solve for C. So I'm going to write this down. Let's solve for C. I'll just put solve C. Okay? So they give us the adjacent. What is the C to this right triangle? It's the hypotenuse. So what do I have? I got adjacent and I have hypotenuse. What trig function uses adjacent and hypotenuse? It's the CA, right, the CAH, the cosine, okay? So it's the cosine. So that's how we know. Students, when they first learn this, their first question is, Mr. Hammer, I just don't know which one to use. I don't know if I have to use the sine, the cosine, or the tangent. Well, how do we know which one we're supposed to use? Look at what they give you and look to see what you're trying to find. They give me the adjacent. We're trying to find the what? The hypotenuse. So, oops, this pen sometimes. Okay? So I write down AH. Which one uses the adjacent and hypotenuse? The cosine does. So that's the trig function that I'm going to use. Okay? Which angle am I dealing with? The 72. So I'm going to do what? Take the cosine of the angle. What's the angle? 72. And that's going to equal the adjacent over the hypotenuse. Which one's adjacent? 8, right? And which one's hypotenuse? It's C, right? I don't know. It's the letter C, so I put it here. So what we're going to do now is we have to do a little bit of algebra. At first, it looks a little bit confusing. Actually, solving for B might have been a little bit easier, but we'll do it this way, okay? I got to solve for C. So how do I get C by itself? Remember, the cosine of 72 is just a number. It's just a decimal, right? It's a number you put in your calculator and you get a decimal. It's just a regular number, all right? So don't let that scare you. Don't let that intimidate you, all right? This is just a regular number. So how in the world would I get C by itself? Well, first of all, that's right. It's being divided, correct? So how do I move it to the other side? I multiply it. You see that? So I multiply it by this side, and then I multiply it by this side. So the C's cancel. Again, what am I trying to do? Trying to get C by itself. Now what's happening with that C? That C is being multiplied by this number. Again, don't let the cosine bother you. The cosine of an angle is just a number. It's just a decimal number. So how do I get a number? How do I get rid of, excuse me, how do I get rid of a number that's being multiplied by C? I do what? I divide. That's right. So what I'm going to do is divide by the cosine of 72. Man, I got this frog in my throat, as they say. So I'm going to divide this side by the cosine of 72. So look, let's clean it up. Let's make it look nice. What happens with this right here? They cancel, okay? So I got C equals, what's all this mess? This is just an 8 on the top, and then what's on the bottom? The cosine of 72. All right, you treat the cosine of 72 just like it's a regular number, because it is. It's just a decimal, isn't it? I can put it into a calculator and I get point blah, 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 whatever it is. All right? So that's what that is. So now, how do I figure out that? How do I find what C is actually equal to? I put it where? Into a calculator, all right? So let's move this over. And what do I have to do with this? Oops, what do I have to do with this calculator? I got to change it to what? To degrees. Now, on this calculator, I got to do it every single time. All right, every time I bring it up, if I close the calculator and I bring it back up again, I always have to change it. If you have a calculator like this, once you change it to degrees, you can turn it off, you can turn it back on again, and it should still be in degrees, right? But just double check, make sure it is, okay? All right, now, what are we going to do? How am I going to put that into a calculator? Well, what is that? It's 8 what? Divided by the cosine of 72. So if you have a calculator like this one right here, like a graphing calculator, this is what you would do. You would hit 8 divided by, and then hit cosine of 72. All right? It's just the way it looks. All right? And then you hit enter, and then there you go. We're going to round it to 1 decimal place. So what's that going to round to? No, to 1 decimal place. It's 25.88. That 8 rounds that 8 to a 9. So it's what? 25.9. So that's how we're going to write it. 25.9. What did we just find? We found how long that hypotenuse is. It's 25.9 what? Centimeters. Okay? You with me on that? So you would have never been able to do that before using this trig, okay? If you only knew one side, there's no way that you could find B and C. All right? So it's kind of handy. All right? It's kind of good. All right, what are we still missing though? We got this side A, we got this side C. What are we missing? Missing B. So let's do it again. All right, let's find, let's move this. You could, okay, it's a good point. You could just do Pythagorean theorem, but here's the problem. It's not a big problem, but it could make a difference. This is a rounded number, isn't it? Okay, it's not exactly 25.9. It's 25 point blah, 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 all that stuff, okay? So it's not an exact number. When you take an approximation and you put in Pythagorean theorem, you have to square it, right? So you're taking an approximation, you're squaring it, which makes it even more approximate, okay? Less than, or it makes it a little bit different than what it should be. It's going to be very, very close, okay? But what I would suggest is that you not do Pythagorean theorem, okay, but you do the trig stuff again. Let's stick with the numbers that they gave us at the beginning, all right? You okay with that? Plus, it gives us another chance to learn how to do this trig, all right? So now, what are we going to solve for? Let's do some different color. Oops, I thought I did. Change it to yellow. There we go. So I want to solve for B this time. Let's use the 72 again. We can do that. Right? So this is the number that they gave us originally. That's an exact number, correct? So I don't want to use hypotenuse, all right, because it's an approximation. Now, there are situations where you're going to have to. Trey, you getting all this? Trey. Hey, Trey. Tapping. Trey, get your head up, please. Okay? Or you can sit with Mr. Sarek. All right. So we want to solve for B, side B. So let's see what we got. We're using this angle. Let's not circle it. Let's just put a little arc right here. We're using that angle. What are these two sides? This side B is what to 72? It's opposite. No, B is opposite. What is 8 to 72? It's adjacent. So I've got opposite and I've got adjacent. Which trig function? It's the TOA, or tangent, right? It's the tangent. Everybody understand how we figured out to use the tangent? Because this is opposite, this is adjacent to that angle, so that's the one that we're going to use. All right, so now let's set it up. Let's go the tangent. We always take the tangent or the sine or the cosine of that angle. Which angle are we dealing with? The 72, that's right. So I take the tangent of 72, that equals what? Opposite over adjacent. Which one's opposite 72? The B. Which one's adjacent? It's 8. Now this math, this algebra, remember earlier I said I should have solved for B first, but I did ask you guys which one you wanted to solve for, and you said C. But this was a little bit easier. So if I want to get B by itself, I only got to do one step. Over here I had to do two steps. I had to multiply by C, divide by cosine of 72. On this one, I only have to do one step. What is that step? Multiply by 8. You got it. So multiply this side by 8, and watch how I do this. I just put it right out in front. I don't even have to put a times. I don't have to put a dot. If I just put it out in front, that automatically means the 8 is being multiplied by the tangent of 72. So that cancels. So now, what do? Use my calculator again, don't I? All right, and so I go 8, and then I don't even have to hit times. All I got to do is hit tangent, and then 72. I like to close that parentheses. I hit enter, and there it is, 24.6. So that would be 24.6. That's what B is equal to. And there you go. Did I solve the triangle? I did. I found all the missing parts. How many parts are there to a triangle? Are there? Altogether? 6. There's 3 what? 3 sides and 3 angles. Okay? So they gave me 72. They gave me 90, right? And they gave me 8. So they gave me 3 things. I had to figure out the other 3. So there's one answer, the 18 degrees. Here's the other answer, C. Here's the other answer, B. So I solved the triangle. All right, we got 15 minutes. I can do this next part in 15 minutes. Now, that was actually the easier of the two things we're going to do today. All right? I know I went, kind of quick. Not really quick, but a little bit quick. You can always go back on the video and watch it and then write it all down again. If you didn't take notes, which you should be doing, if you didn't take notes, you can do that while you watch the video. Again, for the 100th time, it seems like, we are taking a quiz on this on Tuesday, so make sure you understand. All right, here we go. I'm going to go through this. Got a couple things to teach you, then a couple examples. I got 3 examples. I got to go quick. Let me show you this. If I have this, the sine of A equals x. Now, here's what we're going to do. We want to find what the angle A is. In the other problem, they told us the angle. They told us it was 72. So I didn't have to worry about finding that angle, all right? This time, they're not going to give you any angles to your triangle, to your right triangle, except for the 90. That means you can't take the other angle, or 90 minus the other angle. So you're going to have to find that angle. So we have to figure out how in the world am I going to get A by itself. This x represents a number. They'll tell you that number. It could be like 2 over 3, 3 over 5, something like that, okay? So you got to get A by itself. Let me just show you. I'm not even going to ask you. You got to get rid of that sign. If I want to get A by itself, I have to get rid of the sign. Now remember, the sign is not a number. It's not a variable. I can't divide by the sign. But what I can do is take the inverse of the sign. You hear me? Because that's what we do. What if something was being multiplied? What if you had like 3x equals 12? How do I get x by itself? Divide by 3. How did you know to divide? Because you do the what? You do the opposite. Right, the opposite of multiplication. That means inverse, okay? That's the inverse. Everybody hear me? The inverse of multiplication is what? Division. The inverse of addition is subtraction. You with me? Now, this is weird. You've never seen this before, all right? But I'm going to show it to you now. To take the inverse of the sign, we use a little symbol. And we use the symbol sine to the negative first power. It's kind of weird looking, all right? But that means the inverse of the sign. Inverse of the sign. Okay? So, if I want to get rid of this sign, here, let's write it out over here like this. If I want to get this, and I want to get A by itself, I have to get rid of the sign. How do I get rid of the sign? I take the inverse of it. How do I show the inverse? Sine to the negative first. So when I have sine to the negative first times sine, okay, what happens to those? What happens to these 3's? They do what? They cancel out. What happened to the inverse sine and the sine? They do what? They cancel out. But what did I have to do over here? If I divided this side by 3, what do I have to do over here? Divide that side by 3. If I take the inverse sine of one side, then I got to do what? Take the inverse sine of the other side. Okay? So that's what I'm going to do. Let's push this over a little bit so I have some room to write it. After you do these a while, it really is pretty easy. But the first time you see it, it's kind of weird. See what I did? I took the inverse sine of both sides. That got rid of this. Now, what am I left with? I'm left with that angle. So what's that angle equal to? It's equal to the inverse sine of x. Let's do another one. Let's do the cosine. It's the same exact thing. It's just a different trig ratio. What if I had this? What if I had the cosine of A is equal to x and I had to solve for A? Take the inverse cosine. So watch this. So A is equal to what? The inverse cosine, oops, come on, pen. The inverse cosine of x. Sometimes when you do inverse, we'll put that in parentheses like that, just to keep it separate, okay? Make sense? What if you had the tangent? What if I said the tangent of A? Oh, come on. What if I said the tangent of A is equal to some number, okay? They'll tell you this number, this x right here. It'll be like a fraction, a decimal, okay? They'll give it to you. It could be a whole number. How do I get A by itself? I take the inverse tangent. Very good. Is that making sense? So if I want to get rid of the sine that's with that angle, I take the inverse of it. All right, so inverse sine, inverse cosine, inverse tangent. All right, so now, with all that said, we're actually going to do an example, and we're going to use that thing. And I'll show you in a second how to do that in your calculator, okay? There is a way to do inverse sine, inverse cosine, inverse tangent in your calculator, all right? So we will show you that. I will show you that here in a sec. Let's draw a triangle. And come on, there we go. All right, so it's a right triangle. They give you some sides. They give you that is 1, that is 2. If you did the Pythagorean theorem, you would get this to be the square root of 3. And I'll tell you what, let's say we don't know that angle. You with me? So watch what we're going to do. We're going to go the sine of A. Let's do the sine first. We'll do all three. Since we got all three sides, I can do all three trig functions, or ratios. So what is the sine of angle A? It's what over what? Sine is so, S-O-H. What is it? What over what? Opposite over hypotenuse, okay? You got it. So the opposite is the square root of 3, and the hypotenuse is 2. What if I wanted to find what that angle is actually equal to? This is what we're doing, okay? This is really important. All that stuff we learned is all coming to a head right now, okay? This is what we're trying to do. How do I get A by itself? How do I solve for angle A? Very good. Take the inverse sine of both sides. And right now you're probably thinking, I have no idea what this is doing for me. But we're going to pull in the calculator and we're actually going to find what angle A is equal to. Look, they didn't tell you any of those angles, either one of those. They told you it's a right angle right here. They didn't tell you either one of these angles, but you will now be able to find that angle with what we're doing right now. You would have never been able to do this before. Now it's something brand new and we're able to do it. So what we're going to do is put this into our calculator. All right? So there is a button for the inverse sine. If you look here, do you see where the sine is? The inverse is in yellow right behind it. It's kind of like not on the button, but a little behind it. So how do you think we get to that yellow thing behind it? The second function. Very good. So you hit second function and then sine. Look what the calculator does for us. It actually puts sine to the negative first, doesn't it? Just like we did it right here. Now what am I going to do? Put the square root of 3. How do I get square root? Again, I got to hit second function again because of that yellow square root right there. So I hit square root of 3. Now, it put a parentheses there, so I'm going to close that parentheses. And then what? Square root of 3 divided by 2. You got that first parentheses, so I got to close that. So that's what we're putting into our calculator. This takes some practice, all right? You must understand how this works. Now, I know you're going to ask this question because I was about to say this. If you don't have a graphing calculator, how would you do this? Well, you would hit the square root of 3, right? So you hit 3, then the square root, divided by 2, hit equals, and then you hit second function sine. You follow me? I got like 2 people using a calculator. Everybody should have their calculator out practicing this, okay? So if you have a calculator with just one line across the top, you're going to hit 3, then square root, then divided by 2, hit equals, so that gives you the square root of 3 over 2. It's like 0.8660 something, okay? And then, how do you find the inverse sine? Second function, sine, and then that'll give you the same thing as that gave you. And it's 60. 60 what? 60 centimeters, 60 inches? No, you're finding an angle. So what is it? 60 what? 60 degrees. So that's what that angle is right there. It's 60 degrees. Now, you could find this angle super easy. How could you find this angle? It's 30, right. 90 minus 60, all right? They're not all going to be that easy, but yeah, that would be 30 as well. Let me just show you something just for fun. Instead of using sine, let's do the same thing, but let's use cosine. I'm going to show you that the angle comes out to be the same no matter if you use the sine, the cosine, or the tangent. Everybody watching? I know I've been talking for a while, but come on, focus. You only got 5 more minutes. Let's focus, shake it, all right? Get it out of your system, all right? And then give me 5 more minutes. Here we go. What if I use the cosine? Because I got all 3 sides, right? I could use any of the 3 trig ratios. What if I use the cosine? What's that going to give me? Cosine is adjacent over hypotenuse. What's adjacent to 60? 1. What's hypotenuse? 2. So how do I solve for A? I take the what? I got to get rid of the cosine. So I take the inverse cosine of a half. Practice this on your calculator. So let's come up here and do it. So on this calculator, I hit second function cosine. I hit 1/2. 1 divided by 2. You should know that already. And then then I'm good to go because I don't have a square root. I hit, and look at that. It gives you the same exact angle. It should, shouldn't it? I didn't change anything on the triangle. That angle, if it's 60 degrees with one trig ratio, it's got to be 60 degrees with all the other ones. Let's do one more. What's my other trig? Tangent. So let's do the tangent of angle A. What over what is the tangent? That's the TOA. So give me it. Opposite over adjacent. So what's opposite 60? Square root of 3 over 1. Get A by itself. How do I get rid of that tangent? Take the, don't divide. Don't want to hear that. I never said divide. What do? Take the inverse tangent. Right. Okay, we've done that. It's like the 6th time now we've done this. Literally. So it's square root of 3 over 1. Do I need that 1? So what am I putting in the calculator? Second function tangent of the square root of 3. So I hit second function again, hit a 3, close that parentheses, close the other parentheses, and check it out. I get the same exact angle. So it does not matter. If I give you all 3 sides, it doesn't matter which trig function or trig ratio that you use. So I think that's kind of cool, don't you? All right, let's do one more and we'll quit. All right. Oops, I keep hitting this. All right, last one. For the year, last example of the whole entire year. That's exciting, isn't it? All right, so here we go. I wish I had a few more minutes, but I think I can squeeze this in. You writing this down? Okay. I don't know what's going on between the two of you, but it needs to stop. So watch, this is 11, this is 17, and this is A, B, C. And we're going to solve the triangle again. We're going to do it quickly. All right, it's being recorded, so you can always go back and watch it. But I'm going to do it kind of fast because I only got like 2 or 3 minutes, okay? So first thing I'm going to do, I'm going to solve for C. How do I solve for C? I got 2 sides, so I can just do Pythagorean theorem. Oops, 17 squared. Do all that, take the square root, and I've already done it for you, and it's about 20.2. All right, so that's 1. Didn't have to know anything new. That's old stuff, Pythagorean theorem. Let's solve for angle B first, okay? So let's find angle B. Now, you know all 3 of these, but this one, again, is an approximation. So let's stick with the 11 and the 17, okay? Those are exact. So which trig function am I going to use to solve angle B if I have 11 and 17? I'm going to use tangent. Why tangent? Because this is opposite and this is adjacent. All right? Watch how easy this is. Now it is, okay? The tangent of B is equal to what? 11 over 17. Now I can get B by itself. How do I get B by itself? I take the what? How do I get rid of tangent? Take the inverse tangent. So I go inverse tangent of what? 11 over 17. Put it into a calculator. Here we go. I hit second function tangent. I hit 11 divided by 17. Close the parentheses, and you get about 32.9. So angle B is approximately 32.9 degrees right there. I think that's kind of cool because we could have never done that before today. Your homework, here it is. It's numbers. It's a little different than I wrote in the lesson plan. So everybody watch. It's a 1 to 12, 16 to 20. So it's a little less. It's a little less than what I gave you on the lesson plans this week. All right, so there it is. 1 to 12, 16 to 20. That's your last homework assignment. So get it done. All right?
There's still 3 missing homework.
Right, I still probably have them in my folder.